Hey guys, it's Mrs. B here. Welcome to your lesson 7. This is going to be for Monday, April 13th. As we conclude some of the lessons in our unit, we're coming to the last 2 lessons here. So today we're going to talk about transformations and absolute value functions. So far, okay, you guys, we've talked about a couple different types of functions. So we've seen a linear function, straight line, okay, and the equation is y equals mx plus b. You've seen an exponential function, which is curved, with the equation y equals a times b to the x. And today we're going to talk about the absolute value function, okay, which looks like a V. It's very simple. Okay, it's 2 straight lines that look like a V. And our equation for that is y equals the absolute value of x. Okay, with the bars, straight bars. You need to be able to identify that function for certain problems. So let's recap for a second. Let's just talk about what is the absolute value. Okay, when we have these bars and then we have something in it, what does that mean to take an absolute value? So, for example, what's the absolute value? Let's look at the first one here. The absolute value of 2. Well, the whole point is taking the absolute value. When we take the absolute value of something, we take away the bars, and whatever's inside either stays or becomes positive. So whatever's inside turns to positive when we take away the bars. So if we look at example 2, and I take away the bars, the absolute value of negative 2 is also 2. Okay, so the first 2 problems are exactly the same. The first one was positive, the second one was negative, but their answers are both positive. The third one here, if I take away the bars, okay, that negative is still outside of the bars, so it stays. So the absolute value of 2 is just 2. So the answer is really negative 2. And the last one, okay, this is really like 3 times, or I won't put it for the answer, hold on. I'll put it here. This is really like 3 times the absolute value of negative 2. Okay, well, we have to take the absolute value of negative 2, which is just 2. So this is really 3 times 2, which is 6. Okay, so the main rule you need to remember is that anything inside the absolute value bars, once you take them away, it becomes positive. Okay? So the absolute value function. We're going to graph the function f of x equals the absolute value of x. Okay? In GeoGebra. So, f of x equals the absolute value of x. And there it is, just like I graphed before. It's 2 straight lines, starting at 0. So if you look, we're going to graph this. It goes from 0, 1, 1, 2, 2, 3, 3, 4, 4. Very simple. So 0, 1, 1, 2, 2, 3, 3, 4, 4, and the same goes in the opposite direction. Just give yourself a couple of dots. Make sure you put the arrows on the end to signify that the line keeps going. Okay, so this is the equation. F of x equals the absolute value of x. So find the domain. Okay, well, we really have 2 domains, right? Because when x is greater than 0, okay, we're going in a positive direction. So this is the line, right? F of x equals x is this piece right here. So that only exists when x is greater than 0. So I'll put 0. And now we have this one here. F of x equals negative x. Well, that's this line right here. And that only happens when x is less than 0. So we're going to put another 0 for the domain. Okay, it's just understanding the domain. Alright, so most importantly, we're going to talk about some transformations in terms of the absolute value function. Okay, a transformation is just a changing of the line. Okay, it's taking the original equation and it's shifting it in some sort of way, either vertical, up and down, side to side, dilation, which is getting bigger or smaller, or reflection. Okay, so like a vertical and horizontal shift here, a transformation can shift the function up or down, which is vertical, and left or right, which is horizontal. A dilation is a transformation can also expand or shrink the size of the function, so getting bigger or smaller. And then a reflection, okay, to reflect the function over the x or y axis. So these are the three types of transformations we're going to talk about today. So a horizontal shift to the left or the right, okay? When you notice, I'm going to have the original function in all of these slides so we can see how things are shifting. Okay, so this is where it starts, and what I want you to focus on is I want you to focus on the vertex, the center point right here. Okay, so when we horizontal shift this equation left or right, okay, a right shift is going to look like this. And if you look, okay, the original equation was here and we shifted over to the right by 2. And the opposite for the last one. Okay, we shifted from the starting point here by 2. Okay, and this is what the equation looks like. Now, you'll have GeoGebra. The best thing for most of these questions is to be able to type these equations into GeoGebra, and you can see how the functions differ. For example, if I go back to my GeoGebra and I type that second equation in, f of x equals x minus the absolute value of x minus 2. You can see how it shifted over to the right 2 places. Okay, a vertical shift, up or down. Okay, same thing. Here's the original function. Take a look at the vertex. Okay, a shift down would mean we're subtracting by 2 outside of the bars. And if you look, we shifted down by 2. Similar for a shift up, only plus 2. Okay, we shifted up by 2. Okay, a dilation, which is a shrink or expand, so we're either getting smaller or we're getting bigger. So here's our original function, and look at some points here, okay? And then we take a look at our original function for a shrink by 2, and we look that, well, the original function was here, right? And you can see how it shrunk. It got a little bit skinnier or narrower. Okay, that happens when we multiply the original function by 2. And the last one here, you can see how this was the original function, right? Just the regular absolute value of x. And it got bigger. It actually opened up a little bit wider. And that happens when we multiply by a fraction. Reflections over the x-axis and over the y-axis. So a reflection, right? When you look at yourself in the mirror, you see your reflection. And it's not always, you know, if you put writing into the mirror, it looks backwards. So a reflection is just taking the image and reflecting it either over the x-axis or the y-axis. So here's over the x-axis, right? And this is what the equation's going to look like. All we did was we took our starting point and we shifted the lines over the x-axis. Okay? Now for the y-axis, it could be a little bit tricky. Really, it looks the exact same as our original function, right? Because if you think about it, if we're reflecting over the y-axis, well, the reflection is actually already there. And also, if we look at the 2 equations, okay, the negative is inside the parentheses. If I took away the parentheses, or the absolute value bars, that x would be compositive, as would the original function, and that's why they're exactly the same. Alright, that's it for today, guys. Very, very simple lesson. Only a couple problems that are just going to ask you to use GeoGebra to tell me what kind of shift it's doing. And that'll be all for today. Alright, guys, stay safe. Miss you all. Talk to you soon. Bye.